So in the last video, we have talked about the concept called left recursion. See, what is the use of this left recursion concept? So we have something called the grammar, right? So there are some grammar that belongs to a category called non-deterministic grammar. And the point is, the non-deterministic grammars are not handled by the top-down parser. Therefore, we have to introduce some soft and hard rules for converting this non-deterministic grammars to deterministic. So non-deterministic means something called the confusion. Okay, so confused grammar. So we have to produce a deterministic grammar. So how to eliminate left recursion? So we studied in the last video. Now today we'll study one more procedure that is called as left factoring. So what is the factoring concept? The left factoring is a grammar. It's a transformation that is useful for producing a grammar, a deterministic grammar suitable for predictive or top-down parsing. So the concept of top-down parsing we'll study in the next video. So we are doing something called the pre-processing of the grammar. Okay, so we have a grammar. The grammar is already produced. We have to process that grammar. We have to pre-process that grammar so that it is suitable for further step. So what is left factoring? Let us consider we have a rule is of the form, look at that, A derives alpha beta 1 or alpha beta 2. Then what we have to do? See, carefully observe the grammar. Alpha is the prefix, right? In both the alternatives. So what is the common prefix here? Alpha. So let us simplify this grammar. So that is nothing but A derives alpha A dash. So we are introducing one more non-terminal, one more new non-terminal that is called as A dash. So what is A dash? That is the remaining thing in the grammar. So A dash is beta 1 bar beta 2. Very simple, right? Example here. See this grammar we studied. S derives I capital E T S. Another alternative is I capital E T S E S or A, or E derives B. So what is small I here? It is nothing but if. Capital E is expression, T is then, capital S is statement, small e is else. See, what is the common prefix? We have to find out the longest common prefix. So look at the first rule. The common prefix is I capital E T S, right? Okay. So that is S derives, the prefix is IETS S dash or A. Then what is S dash? The remaining things in the rule. So in the first alternative, what is left actually? Epsilon. And in the second one, what is left? ES. Alright. So this is what the alternative, deterministic grammar. Okay, E derives B. So let us write as it is. Okay, it is straightforward rule. Okay, let me explain again one more example. So look at this grammar. Okay, observe the grammar. In the first rule, find out what is alpha, because we have this actually the rules, right? If the grammar is of form A derives alpha beta 1 and alpha beta 2, so what we have to do, we have to first find out what is alpha, then you convert the grammar. Okay, in the first rule, what is alpha? What is the biggest, the longest prefix here? It is ABA. Okay, then what is the conversion? S derives, what is the prefix here? Alpha ABA, right? ABA, introduce one symbol S dash, and another alternative AB, it doesn't have any prefix, right? It is something like epsilon, empty. So we'll write as it is, that is AB. Then we have to define what is S dash. What is S dash? The remaining things in the alternatives. S dash is, what is the first one? First one, what is the remaining thing in the first rule? Epsilon. What is the remaining thing in the second rule? It is nothing but just B. And for the fourth one, it is capital C. For the second one, so what is the prefix? Alpha, it is capital B. Therefore, the grammar is A derives B A dash. What is A dash? A dash derives A bar C. Any problem in the last production? No. So let us write as it is. Okay. So we have algorithms to do this. So the algorithm says that so the input is just a grammar G, that is non-deterministic grammar. And what is the output? An equivalent grammar. Actually, grammar doesn't change the meaning, doesn't change the language. Okay. So it will retain the language, but it becomes deterministic grammar. Okay. So an equivalent left factored grammar. So according to this method, very simple method, so it says that for each non-terminal A, you just find out the longest prefix. Okay, so that is called as alpha. And it should not be epsilon actually. And after that, once you find epsilon, you replace all A production by, okay, that is A derives alpha beta 1, alpha beta 2, etc. alpha beta n and gamma, where gamma represents all alternative that do not begin with alpha. See, A production, so we have many alternative for A production, right? Okay, so many alternatives contain a prefix called alpha, but the last one doesn't contain any prefix. Okay, so in the replacement, we have to keep as it is. Gamma, you just write as it is, and whatever the remaining thing, so prefix, okay, that is write prefix and introduce one new terminal, that is A dash, and A dash is equal to and B1, the remaining thing, B1, beta 2, etc., beta n. Here A dash is a new terminal. Repeatedly apply this transformation until no alternatives for non-terminal have a common prefix. Okay. So you take down this assignment. Students, please note you write all these questions in your yellow book, okay, assignment book with answer. Okay. Assignment on left recursion also. Please do this in yellow book. Thank you.